Hello. Hello. Am I audible to all?
Yes, sir.
Okay, this is a signals and system class for ECE 7 to 9. Who is GR of this class?
So it's me, Damini.
Okay, just send me your mobile number on chat. So this is basically class of signals and system. And before to start this class, let me introduce myself. I'm Parvendra Kumar, assistant professor in ECD department, and I did my PhD from IIT Mandi in optical communication, and my research area is quantum optical communication, Li-Fi technology, and you can see my contact details on the screen. And now here in this lecture, there are 5 units in this course. And in the first unit, the representation of signals and systems, we will discuss about different kinds of signals, continuous signal, discrete time signals, and also about the different types of systems, energy and power signals, the modeling concepts of your systems, linear time invariant system, LTI system, the representation of signals in terms of impulse, discrete time LTI system, continuous time LTI system, properties of LTI systems. We will discuss all these, also the sampling and quantization. We will discuss all these in the unit first. And next, in the second unit, Fourier analysis, we will discuss continuous discrete time Fourier series, trigonometrical exponential Fourier series, properties of the Fourier series, and why the Fourier series is required in analysis of some kind of signals and systems. And correlation, autocorrelation, and the relation of this with the Laplace. And after this, we will discuss Z transform. So Z, just like Laplace transform is used for the analysis of continuous time signal, Z transform is used for the discrete time system. So here we will discuss Z transform, its properties, inverse Z transform, and how can you find out the inverse Z transform, relation of inverse Z transform to the Fourier transform, how they are related, Fourier transform and inverse transform. And after this, we will discuss about the some introductory part of the first Fourier transform. It is a discrete Fourier transform, and the algorithm that is used to find the Fourier transform, discrete Fourier transform, it is the fast Fourier transform. And here we will discuss about this fast Fourier transform, decimation in time and decimation in frequency, Redex 2, Redex 4 algorithms, what are these, linear convolution, circular convolution. So we will discuss all these in this fourth unit, and in the last unit, there are other transforms like discrete sine transform, discrete cosine transform. So why we need the transform, Fourier transform, Z transform? We will discuss about all these, why we need these kinds of transformation. And after this course, you will able to analyze or define the properties of continuous and discrete time signals and system after this course. And you can also have the representation of signals and system in frequency domain using Fourier tool. Why we are using Fourier tools, we will also discuss about this. And uh, you will also able to apply the Z transform to analyze discrete time signals and systems, and obtain fast Fourier transform of sequence and measure its computational efficiency. So these are the outcomes from this course. So before to start, let me give you these are the books we will discuss, the textbook and some reference book, BP Lathi and A Populus. And I think you have also studied, discuss about this book in the ICT and Oppenheim, and these are different profession, all these books and many more books are there. And we will discuss, concentrate only this Oppenheim. So now we'll move to the introduction. So this signals and system forms the building not only of the electrical signal, but also mechanical, civil, electrical, or different contexts. So the stream may be different. And so here, just like this is one kind of system car, and I'm going to input the acceleration, the output is speed. This is one kind of mechanical system, or the fan, input and output rotation. So this electrical signal is converted into the mechanical system, mechanical. So this again another system. Or in electrical, if there is some kind of inductor, and this is voltage Vt and this It. So relation between Vt and It is, Vt is equal to L di by dt. So here, whether this is mechanical system or electrical system. So in one sentence, what we are going here, what we are going to do here, it is in signals and system, it is moved from a specific concrete situation to an abstraction. So specific concrete situation means we are going to forget about the context, whether it is mechanical or electrical. So we forget about the context. So we move from the specific concrete situation to an abstraction. Abstraction means create the relation between input and output. This equation shows the relation between input and output. Input is Vt and output is It. So the relation, to find out the relation between input and output, this is known as the abstraction. So in one sentence, if I say that what we do in signals and system, so it is moved from a specific concrete situation to an abstraction, which helps to understand all these concrete situation better. So in all the situation, whether the mass is pulled by the force or the water flow through the several pipes and a storage tank or electrical network comprising inductor, resistance, capacitance, we have certain kind of input output. And the beauty of this abstraction means input output relation, and the beauty of this abstraction, by looking into the input and output, or you can say system behavior, from the property of the system, it is intuitive that what the output will be without doing any harmful experiment or expensive experiment. So just like if you are going to design some kind of a system or mobile or some kind of any expensive device, and you are going to input, and the output should be your desirable output. If it does not comes, you again work on the system and try to find out your desired outputs, do the some, you are going for the some changes in this. So this system you are going to design, so it is not easy in a real, because every time, just like if you have designed any system and the output is not correct, so you are, this is not good thing that you do the desoldering or change some ICs and all these things, these haptics, and you can find out the output. This is not a good thing. So you will design some Simulink or PSpice model or some kind of circuit on the software, and so you design some kind of system, and you will analyze that if I apply some kind of signal, and I will get my desired output without doing some kind of expensive experiment. So, or maybe this experiment may be harmful. So here, what we will do, we are having input or maybe output or maybe the behavior of the system. So by knowing the behavior of the system, I can easily calculate on the paper mathematically what the output will be without doing experiment. So only on the paper I can find out my output. So this kind of relation or abstraction, means input output relation, can be found in this subject, signals and system. So the system will be anything. It may be the electrical system, maybe the some kind of related to the civil engineering system, biochemical or mechanical system. So we are, so we have to remove this context, whether it is electrical or mechanical. We are just going to find out the relation between input output by knowing the behavior of the system. So we have to analyze the signals and the system in this case. So just like if I consider two systems, mechanical or electrical, force voltage analogy means uh, in mechanical system, you know, if I apply a force on a mass, then this mass is going to move, suppose in this direction. So this acceleration, you know, F is equal to ma, or I can define by this equation, F is equal to m dv by dt. So this is input, this is velocity, this is output, and this is system. So here, this is the relation between input and output, and this is known as the abstraction, and this equation is the description of this abstraction. If I am having an electrical system, just like this is my electrical system, Vt and It. So the relation between input and output, it is, you know, Vt is equal to L dit by dt. So from these two equations, you can see Vt is like force in mechanical current, It is like velocity, and this L is behaves like mass. So this is system in electrical domain and this is system in mechanical domain. So these two equations are similar. So force voltage, if force is voltage, if force is voltage, then current will be velocity and the inductor will be mass. So here you can see in these two equations, if there is one system, forget about whether it is mechanical or electrical. The input is xt and output is yt, and the system is A. So I can write the equation xt is equal to A dyt by dt for this kind of system, these two systems. this system and this. If I compare these two systems, for example, so here this is the force in the mechanical system, this xt, and this xt will be the voltage in electrical system. This yt is the current in the electrical system, and yt is the velocity in the mechanical system, and system is a. So here what we are doing here, what is this, we are just going to find out this relation, this kind of input output relation. Input is xt, output is yt. So this system, I am not interested about the system whether it is mechanical or electrical. So the context I'm going to forget about this. So remove the context whether it is mechanical or electrical. So remove the context and we are moving towards the abstraction, means input output relation. So this is the signals and system. So we are not going to bother about, we are talking about the electrical system or mechanical system. We can just find out, just like, you know, I told you this thing, just like another equation, friction. So force, it is rho v, frictional constant, and in electrical it is similar, v is equal to r it from the resistance. V is related r it, similarly this. So these two systems are same. So these two systems can be defined by equation xt is equal to a yt. A system in electrical it is r, in mechanical it is rho. So similarly, if there is friction on the surface and I'm going to move the mass m by the force F. So equation, the differential equation will be F is equal to m dv by dt plus rho v. And in the electrical system, L and R are here. So voltage will be equal to voltage drop here plus voltage drop here. And voltage drop here, it is L di by dt and R it. So here you can see these two equations are similar. In electrical, it is voltage. In mechanical, it is force. So I can write xt is equal to A dyt by dt plus b yt. So it is one system, it is one system, it is another system. So here you can see system A and system B, and the relation between input and output is this. So here you can see, if I will talk about this equation, I'm not saying whether it is mechanical or electrical. I'm not going here in this relation. B may be R, or Y may be IT, or maybe rho t, VT, velocity, maybe anything. So I'm not interested whether it is current or velocity, whether it is voltage or force. So this equation is generalized equation. So here in mechanical system, xt is force, in electrical system, xt is voltage. So I can write my differential equation like this. And this equation is basically known as the linear constant coefficient differential equation. And for continuous case, we are going to use differential equation. And for the discrete case, we will use difference equation, just like this. In discrete case, we'll use difference equation. And this differential or difference equation is basically the description of abstraction. Description of abstraction. Abstraction means the relation between input and output, and this is described, the relation, this equation describes the relation between input and output. So this is the description of input output relation. Are you getting me? Hello.
Yes, sir.
Okay. So in abstraction, we are having input, output, and equation, differential equation that relates input and output. X is equal to a1 dy t by dt plus a2 yt. So abstraction in this, I'm not going to bother about what is the context, whether it is electrical or mechanical. So from this equation, in electrical, this xt may be voltage. In mechanical, this xt may be force. In yt, in electrical, this is current, and similarly in mechanical, it may be velocity. So here we are just in this, we can forget about the context, whether it is mechanical or electrical. We move, or we remove the context, and we move towards the abstraction. This is one kind of thing in the signals and system we do. So as I told you, why we study signals and system, because we want our experiment on paper, expensive experiment. So there is no need to really have a practical experiment that may be harmful to you or may be expensive, and we just want to find out what the output of that kind of system which I have designed. So I'm going to design a system, and on that basis I want to find out the output. So if I know the behavior of the system or properties of the system and signals, also the different types of signals, I can easily find out what the output will be on the paper. So this is basically the signal system does. So this is very important subject, as I know, because there is no context, no stream. It is beyond from the stream, electrical or mechanical. So this is very good subject you have to study. So before to study more about signals and system, because signal is basically a function. So first of all, we have to define what is a function basically. If this is not a function, I cannot define a signal. So actually function is basically a, depend on some independent variable, and that independent variable basically in almost all the system we use is the natural domain. This is time domain. Time domain is the natural domain. So first of all, function is basically a mapping or a rule by which I'm going to map my elements to another, or the image of this here. So here basically just like there is a function x square plus 1. So 1 is going to map to 2, and if the value of x is 2, it is mapped to 5. So I'm going to map from here to here, and the relation R is basically 1 is going to map to 2 and 2 is going to map to 5. This is one-to-one relation, every element having single image. This is one-to-one mapping. So if there is one-to-one mapping, this is known as a function. And also, if here you can see A is mapped to 1, B is also mapped to 1. So here this is many to one mapping. Many means two are mapped to single element. Many to one. This is also a function, but this is not a function. One to many. One. This A is mapped to 1 and also mapped to 2. So many to 1 is not a function. This mapping is not defined as a function. Only two mappings, 1 to 1 and many to 1, are the function. And 1 to many is not a function, because there is one element having two images, and the function with this relation is not defined. So first of all, if you are talking about signal, signal is a function. So be prepared about this. The function may be one to one or many to one, not one to many. So this is introductory part of this signals and system. If you are having any doubt, you can ask now. Otherwise, from next lecture, I will start what is signal and different kinds of signals. Any question? Yes. Yes, no तो कर दो कम से कम.
No, sir, कोई doubt नहीं है.
Okay. Thank you then. You can leave.
Thank you, sir.
ट्यूटोरियल के नाम से होता है ट्यूटोरियल इवैल्यूएशन 1